start here with a video on the simple flat earth test that you can do. It won't cost any money. You don't need a camera unless you want to record your observations. You don't need a telescope, but you could use one if you have one. The only thing you'll need, you can get one of these $1 at Walmart, and with the batteries, and so that's all you'll need. First I'll explain the simple test, and then I'll give you some of my data that I've been getting. From 2 or 3 miles away, place a light on the ice, preferably late afternoon, because during the day you tend to get distortion, and at night it's a little bit difficult because you can't see anything except the light, and it's good to have a view of the surrounding landscape so that you can have a comparison and a perspective of it. So anyway, you go 2 or 3 miles away. At 2 miles, the dip should be 32 inches, and at 3 miles it should be 6 feet. My test was conducted at 3.7 miles, which reflects a dip of 9 feet. The light is on the ice, and I started from high and I went to low, and when I was laying on the ice I could still see the light. Supposedly 9 feet of curvature, I don't believe it. This one, what I did, just in case there were some naysayers who would say, oh well, you just kind of see around the curve. So I placed a block of wood. The block of wood is about 1,000 feet away. The light is 3.7 miles from me. So what I did is I started high again, I went down low, and from 3.7 miles I went down, and first I placed a 4-inch strip of wood, which you can see there, and I noticed that when I got right down to the ice, basically the piece of wood split the light. That's the only way I can describe it. I do have some other posters here to show what it looked like. With the telescope I had a better view than I did with the camera alone, because I have a okay camera, but it's not one of the super, like a PX 900. But anyway, so I went down, and I noticed when I was all the way, when I had my head on the ice, again, like I say, you can do this without a camera, without a telescope. When I had my head all the way on the ice, the 4-inch block, which was actually about 2 inches submerged in the snow, I could basically, I split the light. I could see it was half obscured. The light at the end I placed about 3 inches off of the surface, and the light was about 6 inches across. The reason I would suggest placing it a little bit up is because on like the frozen lake, we had snowmobiles going across, all kinds of things, so there was definitely a tiny bit of, snow or whatever that would be a couple inches high. But anyway, and then when I placed the 12-inch block, which again was probably 2 inches sunk in the snow right to the ice level, I noticed that when I lowered my head all the way to the ice, I could not see the light. At that point it had obscured it. So what I'm saying is you would have to say that, well, you can see around 9 feet of curve, but you can't see around a 12-inch piece of wood. Well, that doesn't make sense. So anyway, let me see if I have any other photos, just a couple. This again was right down to the ice. Another one I had, this is a little bit higher up. You can tell with reference by that cone on the right. When the cone is sticking above the ice, that means I'm right down to the ice. What I had is the white light on the bottom and then a red light above the white light. And this is one where I just, again, I'm right to the ice there, and you can just see the light. Well, it's an ideal time. Students, university professors, teachers, Christians, homeschoolers, Christian students, seminary professors, it's an ideal time. Go out on the ice right now while it's frozen and do your own research. It's flat. There is no curve. It's an ideal time. Like I said, you can put a flashlight 2 miles away. That should be 32 inches of dip. 3 miles away, it should be 6 feet below your eyesight. You could probably even go more if you have a bright light. Well, thank you, and God bless you, and Jesus loves you.